Welcome everyone to the NRRA quarterly joint meeting. Again, the idea here is to share topics that are interest for all our NRRA members in a kind of a short format instead of the team meetings that we have every month. So this is taking place instead of our flexible, rigid on and on team meetings. So welcome, and I hope you enjoy this. And we're always looking for ideas of how to improve this, so don't be shy. So today's theme, what's kind of interesting here is this is I guess here's our agenda for today. Again, I'll give a quick update on NRRA. Geotechnical team will be talking about a pooled fund study. Either David White or Tom Yu will be joining us. And for Raul's team, Tom Burnham's team, the rigid team, is going to be kind of giving an update on kind of this alternative cement materials that we've been placing with Prashad. And intelligent construction team, Kyle's group will be talking about a survey done from TSD and NDT projects. So he'll be taking care of that for us. And along with the preventative maintenance, we'll be talking about the rumple strip study, that's NRRA study that Dan Schwartz, Asphalt Materials, will be presenting on. And following up, Kurt Dunn's team, the flexible team, will be talking about some work that NCAT's doing with Chen Chen on the standardization of the SIP calculations for Hamburg wheel tracking tests, so the running test per se. First of all, I want to thank all the chairs for all the fine work you've been doing and all the stuff you have to do to make this successful. Again, thank you very much for that and for the presenters today. So start out a couple things for my NRRA update. Be real quick. You all know about the conference coming up April 20th through the 21st. The agenda is online. Everything is shown there. Great work by the teams to put that together. The registration is open now. Again, it's a very fair price for registration. And again, we'll be honoring Maria Maston and Lev Skvanovich on their achievements, contributions, and friendships they've had with all of us. So be a great time to give some recognition for people well-deserved. And the theme of this talk for me is I'm going to talk about a little bit about irises. My father grows irises and hybridizes them, meaning that he takes two flowers, he crosses them, he waits for a seed pod. 2 or 3 years later, there's a bunch of flowers. He pulls up most of them, but then keeps 1 or 2 that have traits that he likes. So since my dad hybridizes irises, we have an iris named Anna Lou, which is my first daughter, and a flower named Greta. So we all get flowers named after us. And I have a couple more pictures, but again, thinking of spring. We also seem like we missed one in there. The research pays off is coming up this February 19th. We'll be talking about Utah's experience with highly modified low air void for extreme performance by Dave Johnson, the Asphalt Institute. Again, this is kind of a mix that I know MnDOT has been interested in, and so we'll be sharing that through the Research Pays Off this February. So hopefully you got that all on your schedules. March 18th, we'll be doing some stuff with NRRA Dynamics. This is a MnDOT project with a group from Denmark and the University of Minnesota. But again, what we're kind of looking at here is a floating car, meaning it's not actually a floating car, which I really was excited about when I heard it first time. But it's actually the data that's being collected from all the different fleet vehicles that are driving around on our roads and how that data might be used for roughness and finding different areas of pavements that need attention. So that's something we thought that would be an interest to a lot of groups. Again, we're always looking for additional topics. Lauren will need those coming up after March, so let us know. So the next flower, of course, my dad made one called Lubin, which is my wife's name is Linda Lou, and my name's Ben. So this is the flower that I had to share with my wife. My kids get their own flowers, but here's a flower named after me, my dad made. A couple other things finishing it up. 2025, 2026, again, we're going to have construction on our main line. The contractor is going to start around April 15th. So we're going to have no closures for the next couple of years. So we'll be doing pathways testing, dynamic testing with live traffic and with our truck in traffic. But again, our last closure is going to be in April, and we're going to be trying to get a lot of things done. So again, as they build 3 lanes through the old westbound and the old eastbound will be 3 lanes. Min Road will still stay 2 lanes. But we're going to have limited access for a little while until we get that figured out. Just letting you know on that. Related to construction for 2025, again, we've been kind of talking about doing things, and we've been getting different ideas in. But again, we're still looking for ideas, and there's been a few people that have companies, groups that have presented some ideas. We're going to have to prioritize those and figure out what we're going to do. I was going to develop a formal email coming out soon, kind of defining that process. I was kind of equating this to like when that friend of yours that never commits for Saturday night because they might find something else is better coming up. I need to not be that person that's doing that. So I was going to work with the different teams and developing a June 1st kind of deadline for terminating a plan for 2025 for a low volume road. So then we can start planning. And that gives a deadline date for people to do that. So I'll be working with people here at MnDOT on that process and get that out to everyone so we can kind of determine that and kind of move forward for 2025, 2026 construction ideas for Low Volume Road. And also, I think all the teams, if you could mention it today, maybe just note something about your $100,000 ideas that you're developing for March 15th for the executive team to consider. Eob, I'll take your question in 1 second, but I had to say that my dad also made a flower named Jan Baby, which my mother's name is Jan. So we're all covered with flowers, and that's it for my presentation. So Eob, you had a question?
Yes, Ben, that flower confused me. I make me forget my question, but yes, yeah. When you're looking for ideas ideas, I was just curious, what happens to the ideas that we received in the past years? And is it possible to have like a database that can be shown in the NRRA website with all the ideas from this year, from past year, and maybe prioritize them?
Let's work on that. I guess there's a few things. Are you talking ideas for construction or ideas for research?
In this case, I was talking ideas for construction, but it may apply to everything. If we can have just all the ideas that we have received in the years, some of them we act on, some of them we just leave them there
Right.
pending. Maybe. But just to have a look instead of sending another idea,
Okay.
or just to
So
see
you
what
can
has been
build.
done.
You can build on it then. Yeah.
Yeah, I was thinking.
That side makes sense. Let me talk to you more on that, and then we'll talk to others on that too. But thanks, Eob.
Thank you.
Any other questions before we go into the teams?
Yes, Ben, we might want to point out that we have not identified a pot of money for construction this year yet.
We have not, and that's one of the.
It should be kind of important here that we're not charging ahead with plans at this point. We are certainly seeking funding. We're pursuing many avenues, but at this point, there's no hard money available yet. But we're working as best we can.
Thank you, Tom. Appreciate that. All right, with that said, we'll start out with the geotechnical team, then the rigid team, the ICT, PM, and flex team. So Raul, the show is yours.
Thank you. Good morning, everyone. Before I give the floor to David White, I think David White is on the line. I don't see Tom Yu from Federal Highway. I would like to provide some context and just build a case on why this pool fund that they're putting together is important for us. Ben, do you see the slide? Do you see the presentation right now?
Yes.
Do you see some colorful maps? Okay.
I see some beautiful pictures of rectangles.
Okay. All right. So building the case for payment foundation uniformity and why it's important. for the past, Minda has been working for about more than 20 years on this topic. We recently, at the subsurface, geotechnical subsurface research unit in the research section at Minda, we have been working on connecting the dots. And what I mean by that is trying to relate uniformity of the pavement foundation with performance of your road. We are very fortunate to have Minroad to do this type of work. So I'm just going to show you two case examples of why uniformity is so important from mapping that we have conducted in Minroad in 4 sections. So right now I'm just showing you pavement foundation mapping using intelligent construction. In this case, this section was built in 2017. So we have about 7 years of active usage of these cells. This is in the low volume road. Here on the left side, you see the cross section. It's an asphalt road with a foundation base made of recycled material, a combination of RCA and RAP. And it's all built on large stone subbase and then on a clay subgrade. So here on the left, you see as the cell that has more or less more uniform foundation. You see some changes in color. The color indicate the stiffness. Sorry for the people that don't like SI. This was submitted for a publication in TRB, and we have to do it in SI, so megapascals, the units of stiffness. And then on the right, we have one that you can see more change of colors, so more non-uniform condition. And not surprisingly, I mean, us engineers will expect that when you have a lot of non-uniform conditions and you have contrasts in your stiffness, you will expect weird things happen, discontinuities, stress, cracks formation, and all that. So not surprisingly, we start to see now measure cracks where we have the highest concentration of non-uniformity. So kind of indicating that, yeah, it is very important to have 100% coverage and a uniform condition in your foundation. So it shows kind of we're trying to build a case on why we should look for that. And another one here. So this is a nice example. These two cells, the low volume road, because they have the same foundation. They sound the same foundation. It's just in one we didn't do at the end of a decent job towards the compaction in the transition zone. And funny enough too, we do test rolling. So test rolling can give you a good indication of the condition, the general condition, but it's not as precise and doesn't give you quantification of non-uniform spots. So that's one example I want to show. And then the next one is, let's see if I have here, cell 188 and cell 189. In this case, 188, the foundation is made of limestone, virgin aggregate, and 189 is made of recycled material. Here again, visually speaking, and we have the numbers for coefficient of variation, this 189 shows the highest variation in stiffness of your foundation. And where there is a high concentration, changes in stiffnesses, when you have high uniformity is where we start seeing also cracks coming up. So we're going to keep connecting the dots. We're going to keep monitoring these cells. Fortunately, and thanks to Minroad operations, and we have been consistently measured when we can. We have been mapping the foundations of all the cells with the help of NGOs, with the help of UTEP with Sohail. We have been collaborating with some of our members, helping us out with this effort. So I just want to show you that why it is important, this topic. And then with that, I'm going to give the floor to either Tom Yu or David White to talk about their solicitation in this pool fund. Dave, are you on the line?
Good morning. I am. Let's see, is Tom on?
I didn't see him, so yeah.
Okay.
I have the slides for him. If you want,
Perfect.
I can navigate in the slides. So I'm gonna show it here. All right.
Okay, great. Thank you. I'll walk through these slides on the proposed pooled fund, engineering the foundation layers for long life, low carbon pavement systems. And what a great background picture to warm us up this time of the year. I'm not sure the story behind that, but that comes from Tom. Okay, thank you. The solicitation has been posted. I'll go ahead and put that in the chat. The champion for this is Chris Brackey with Iowa DOT. And the manifestation of this really comes from 3 years of workshops at TRB and the work at Minroad and other agencies that are focused on pavement foundation construction. The objectives are to demonstrate intelligent technology for ensuring quality of pavement foundation construction with 100% modulus verification, similar to what Raul showed, to use automated plate load testing to build a database of mechanistic parameter values for foundations, and then develop guidelines for pavement foundation design to ensure good long-term performance of the systems, with giving consideration to resiliency and also durability. Next slide. The proposed project activities involve technology demonstration from demonstration projects using 100% mapping and in situ tests for validation. Technical support will be provided for the pilot project. So it's envisioned that each participating state would have the opportunity to build a section of roadway as part of the demonstration. Establish processes for quality assurance and verification, including draft specifications, and then develop guidelines for pavement foundation design. This was really the last 3 years at TRP workshops has been an important discussion where new tools are needed to design pavement foundations to meet pavement design requirements. So establish best practices. And if you've heard Tom talk about this study, deterioration, durability over time is very important to him as part of the project. And it's envisioned geotextiles and different types of stabilization would be an important part of the design element. And then addressing resiliency. The proposed study is 5 years, anticipating up to 3 pilot projects per year, and they're seeking 10 state highway authorities for commitments. The funding level is $30,000 per year for 5 years, starting in 2026. And Tom can speak more to the commitment that he's working on from the FHWA side. I think the QR code works here, but if you look at the chat, there's a direct link to that solicitation that was recently posted. Thank you. The last thing I'll mention, Raul, is the save the date. Okay, perfect. April 8th and 9th, Tom is funding a peer exchange to invite folks in to talk about engineered pavement foundations, to talk about this pooled fund initiative and the scope. That's coming up pretty quick. Details from the planning committee are coming together just this week and next week. One of the locations, Minroad, has offered to host this. So thanks for Minroad for that offer. Tom would be the primary contact on that. I'm happy to help anybody that's interested in getting connected for that. I know for the state DOT folks, it can take a couple months to get approvals for travel. So we'll have to move pretty quickly to get that stuff in place. But it should be a great event. All agencies will have a chance to share and talk about best practices and challenges and how they're using technology. So stay tuned for that. And I would just say in the time bank, feel free to reach out to me or Tom directly to get plugged in on that. We'll get more details out shortly.
Thank you, Dave. Any questions for him?
Yeah, this is Deepak. Can you hear me?
Yes, Deepak, we can hear you.
Yeah, this is really a good one. I have a questions. Are we talking about for both pavement, or we are only trying to develop some guidelines for the basis, generic guidelines for both?
Yeah, that's a good question. And I think right now the emphasis would be both pavement types and addressing subgrade issue and aggregate base issues as well.
So this will be this will include with the drainage, right?
Yes.
Thank you.
Thank you, Deepak. All right, Ben, I think we are on time, right?
And you got 7 extra minutes.
Oof,
Raul, you can
this is-
always say that you can extend, you can go longer. If not, thank you very much, Raul, and thanks, David, for that update. And again, this is being recorded, so you'll be able to see this later if you'd like. With that, Tom, do you want to go ahead and share the rigid efforts that are going on and have Prasant talk a little bit about alternative cementitious materials? Thanks, Tom. You're muted, Tom. You're a strong silent type right now.
Sorry about that. Yeah, hopefully everyone recognizes that on a global scale, there's an effort to reduce the amount of carbon involved with concrete. And so back in 2021, we already started to see the writing on the wall that we need to start investigating the next generation of concrete pavement materials. So we embarked and built 16 different test sections on the main line of Min Road, and then we added another 8 this year. So we're fully committed to trying to test out and understand the next generation of concrete pavements that contain lower carbon contents. And what we're going to have to do, a presentation today by Prashant Ram with Aptech is he's involved in one of the 3 studies started in 2022 that it's monitoring the performance of the sections that are labeled as alternative cementitious content. So Prashant, if you want to go ahead and kind of share what you've been finding so far, go ahead.
All right, with any luck, I should be sharing the right screen, I think. If you can give me a nod down that my screen is showing properly in presentation mode.
Yep.
All right, excellent. All right, thank you, Tom. So as Tom mentioned, we started this project back in 2022. I think it was a series of 3 projects. One project was focused on carbon capture type materials. The other project was looking at alternative pozzolanic materials for use in concrete pavements. And the third project was the use of alternative cementitious materials. So that is what I'm going to be talking about. Just a quick 10-15 minute update uh, on the project here. All right, just going back to the study objectives, Tom mentioned like that environmental sustainability and reducing the carbon footprint from concrete mixtures was the primary motivation behind this project. And even if you look at the PCA's 2050 roadmap, you will see that alternative cements are one strategy that's been proposed in the pathway to net zero, right? So this project is essentially doing that. And the objectives of the project were to determine the characteristics that we need to be considering while selecting and placing these materials. What do we need to be thinking about when designing these materials? And more importantly, when producing and placing these materials in the field, what are some of the key aspects to consider? And a lot of these materials are unique. So if you look at an alternative cement, it is it's no different from any other cementitious material that you would use, but it is as As defined in the ACI standard, it is an inorganic cement that can be used for either a partial replacement or even a complete replacement of Portland cement in your mixtures. Right? And specifically, these cements are not necessarily covered by applicable specifications or standards that are in place for Portland or blended cement. So those are the materials we're looking at. So as I mentioned earlier, quantifying environmental impacts, looking at the carbon footprints and comparing that to traditional paving mixtures, that was a big component of the study. And more importantly, we want these materials to perform either equivalent or even exhibit better performance to the materials that we've been traditionally using. So performance is central to it. That's why we have a long-term monitoring aspect in this particular study. So looking at the work tasks, so we had 9 original work tasks that were defined as a part of this project. The first initial task was to just conduct a literature review on the different types of alternative cements out there. And then the next part, the task 2 was mostly construction testing analysis. A lot of testing was performed in the laboratory to test these mixtures, and all the results of those mixtures, of those tests, have been documented, and those reports should be available on the project webpage on Mentor site if you search for it. And then we looked at constructability evaluation, right? How feasible it is it to use these materials on a large scale? So one of the requirements of this particular project was that we should not need the use of any specialized construction equipment. We needed to use the slip form paver and also all other equipment that have been traditionally used with slip form concrete paving. So no modifications were performed to the production operation and also the paving operations. And then tasks 4, 5, and 6 mainly deal with the performance update after year 1. What did we find, not just from visual inspections, but also from the testing that was conducted at Mentor and also the data that was collected from the embedded sensors. And task 5 and 6, the same thing for years 2 and 3. And task 7 is looking at the sustainability evaluation. I'll talk about that briefly, but that's something that is underway, and that's in the next steps. So just looking at the materials, right? We had 4 materials and 1 control. Looking at the first material was the ultra high materials. This one had 0% Portland cement in it, and this was 100% replacement for Portland cement. And originally, this was supposed to be a geopolymer formulation, but what we eventually ended up getting, we don't know what we ended up getting, but all we know that it contained 0% Portland cement. And there were some initial difficulties in dialing down the mix design. But we eventually did get it placed, but we were only able to get a few slabs. Originally, I think only 37 foot was placed, and then they had to remove some of the material, and then we were left with 2 slabs after year 1. But when we went out for the year 2 inspections back in August of last year, we saw that the 2 slabs had also been removed. So I wouldn't say the material itself is not suitable for concrete paving operations. We just needed more time to figure out what the ideal mix design would be for this material. So if given another opportunity, I think Windroad would probably welcome doing another trial for this material. So when we went out there for the year 2 inspections, we did not have any material in place, and this has been completely removed and is being replaced. And then looking at the next cement there, the Ash Grove blended cement. So originally this was supposed to be an LC3 cement, but what we ended up putting in place was type 1P30, a Portland pozzolan cement. It had 30% replacement with calcined clay. And then the Terra CO2 Opus SCM, that is a proprietary manufactured alternative cementitious material. I think they also call it a manufactured fly ash. And there was a 35% replacement for Portland cement. And the next one, test cell 2218, is just your study control, which is a 1L10 cement with 30% fly ash. And cell 2223 is your continental blended cement. That would be a type 1L20 cement that was used. All right, looking at after 2 years, how did these test cells perform? So one thing that we noted right after construction was that we saw some recurring distresses in almost every single test cell, approximately a foot from the outside shoulder line. And we saw that it was more severe on the approach side than the lead side. So the possible causes we thought could be combined effects of irregular panel elevations or snow plowing, but we did get a straight edge out there in the field during our year one site inspections, and we did not notice anything out of the ordinary in terms of elevations. We thought snow plowing could be an issue, but it really didn't look like that would be the major cause. But it looks like what we hypothesizes the most likely cause is probably due to the slip form paving operation. It could be an effect from an irregular vibrator. And we saw that on almost every single joint. It was probably more pronounced on certain joints, and we saw this distress actually progress as a part of year two inspections. And just a quick drone footage that we took as a part of year one site visit. So you could see these joints there, approximately a foot from the outside shoulder. Almost every single joint you can see that there's spalling there, and in some joints where you don't see the spalling, you would see kind of a fraying along the joints there. So this was pretty much widespread, not just isolated to one particular mixture or material type. It was almost widespread through every single test cell on all the three projects that were implemented back in 2022. And other general observations from our year two site visit, we did see some additional damage, some new additional distress progression, both in the longitudinal and the transverse joints. We did see progression of the joint and corner deterioration. The spalling in some cases had deteriorated further. And in that, as you can see, an example of one of those spall joints there. You could see some debris also within the joints, and then it could be from a combined effect of the initial damage from the joint sawing operations. I think the timing of the joint sawing operations could have been potentially challenging for the contractor out there. And also the other thing is progression of the damage, probably due to inadequate application of the curing compound. And also the one other thing that is often overlooked is after the joint sawing has been performed, the reapplication of the curing compound of the joint is not necessarily performed in a lot of cases. So that could also have resulted in a compromised joints, and this could result in further deterioration that we could see in future years. And this is cell 2209. Like I said, after year one, only 2 slabs remained. And then these slabs have been completely removed prior to the year two inspection. So we do not have this material on site anymore. And cell 2214, this is your ash grove blended cement. This is the cement that had 35% of the calcined clay. We did see the joint spalling issues. Some of those joint and corner spalls had progressed to further severity, some medium, maybe 1 or 2 high severity spalling locations, as you can see from the photos there. And a few areas of isolated pop-outs, and not just it was not over the entire surface, but isolated pop-outs that you could see of larger rock there that we noted as a part of the year two site inspections. And we did note 1 or 2 areas of what we called initially as shrinkage cracking, and that a lot of it has not progressed a lot. A little bit of progression that we saw after year two, and there was one area along the shoulder there where we did see a pattern of parallel cracks, and we probably, this pattern that you see is probably due to a moisture differential that you see in the near surfaces of concrete, maybe due to over finishing. But it looks like MnDOT did take some cores there. We have not seen data from those cores, but this could very well be due to moisture issues. And this was only localized to 1 or 2 particular slabs in the shoulder area, not really widespread throughout the section. And our next material, Terra CO2, this is the manufactured fly ash. They call it the Opus SCM. And for this one, and one item that I did overlook earlier, when we looked at for ash grove cement in year one, it was the pavement condition index according to the ASTM standard was 99, and then in year two we did see a big drop, almost a 10-point drop, primarily due to the progression of distresses into the medium severity and some to the high severity. It's still in generally good condition, but we did experience a big drop from year one to year two. And Terra CO2, and we did not see a lot of progression and distresses from year one to year two. A few of those falls had progressed onto higher severities coupled to medium severities, and we did see one or two new spalls, but no new cracking. One area where we did see a little bit of the shrinkage slash map cracking pattern in year one. It had not really progressed a lot, and as you can see from the conditions there, almost identical conditions from year one to year two in terms of the pavement condition index. The next material, cell 2223, was the continental cement. This was the type 1L20, the blended cement. And again, not much progression in terms of the stresses there, but as you can see, that you can see some debris there within those joints from those corner walls. We expect to see a little more damage in future years. And then we also did see some emerging distresses, as you can see from the picture on the right. Again, you do see some joint misalignment there, and also some damage emerging on the corner. So we can see maybe in year 3 and 4 we could see some more corner spalls develop in this section. Again, when we look at the pavement condition index, year one was at an 89. Year two, not much of a drop. As I said, not much progression in distresses from year 1 to 2. And then 20 to 18 was a study control, your standard MnDOT paving mixture. And then when we went out there for the year one inspections, we did see some irregular surface wear on certain slabs, and that had continued to exhibit further deterioration. You can see a little more scaling of the paste. Paste has come out in certain locations where we did note some irregular surface wear in year one. And in terms of pavement condition index, it still seems to be performing very similar to what we saw in year one. And we do see some joints where you can see a lot of fraying along the joints, not necessarily progress to the condition where you would actually document it as a distress according to the ASTM standard, but we do see some fraying and some incompressibles that were lodged in those joints that could potentially result in further joint deterioration in future years. And taking a quick look at some of the data that was collected at MnDOT, not necessarily spending too much time here. This is the right quality data collected using two different equipment. One was the LISA device on the left side of the screen there. On the right side of the screen is your automated data collection equipment from your park-based van. As you can see, most of the data that was collected falls in your good range as far as IRI is concerned. We did see a little bit of a drop from years 1 to 2 in the IRA, but again, one thing to keep in mind is these are pretty short test cells, right? 220, 50-foot test cells, and these numbers, more than the absolute value. What we are really interested in looking at is how these values progress over time. We did see a little bit of a drop, but not too significant. And then one notable observation was that the cell 2214, the ash grove, exhibited more, typically higher IRI values in the 80 to 100 range when compared to the other materials that were slightly, between the 60 and the 80 range. And in terms of surface friction, the rib tire numbers, as you can see on the left side of the screen, that most of the values were over 40, 45, between around 48 to the 60 range. And as you would expect, the smooth tires slightly lower values, but we did see a bigger drop from years 1 to 2 in terms of friction with the smooth tire testing at 40 miles per hour. And load transfer efficiency, and nothing noteworthy here between years 1 and 2. It seems to be relatively consistent, about 80 to 90% in terms of load transfer efficiency from the approach and lead slabs. Not much different in the driving and passing lanes, and not much to say there was a significant difference when we looked at years 1 and 2 data. And in addition to some of these tests that were done at MnDOT, as you know, always with testing at MnDOT, it's not just the kitchen sink that MnDOT throws; they throw the entire kitchen at it, right? So we had almost every single conceivable sensor out there at the market was used in these test cells, and there is a report documenting what sensors were used, where they were placed. I'm not going to go through the details, but a little bit of data from those embedded sensors. And so this one is showing you data from the thermocouples that were placed, and they were placed at different depths, as you can see. Some of those darker lines, the darker blue lines and almost black lines that you can see in the screen there, those are data that from the embedded sensors that were deeper. down in the structure, and there's not much noise from those sensors as you would expect, and also the ones that were closer to the surface, that red lines you see, more temperature cycling, a lot more noise there. Again, this data is being collected continuously, and this is some example data from cell 2214, the ash grove test cell. This is the vibrating wire strain gauge data. And again, as I mentioned earlier, with the right quality data, we are not necessarily focused on the absolute value. We are trying to look at the trends over time. And this data has been looked at for all the test cells, nothing out of the ordinary, the expected cycling that you would expect to see from these sensors. And we will continue to monitor this over time. And if there is cracking or pressure relief, we would expect to see an abrupt drop there. But so far, none of the test cells have actually exhibited any mid-panel cracking. There was one that was there right after construction, but that had already been replaced, and we have seen no panel cracking at the end of year 2 in any of the slabs. And again, another experimental sensor that was used to measure joint opening. This was installed at a 7.5-inch offset from the joint and at a 3-inch depth from the surface. And in some cases, the measurements that we saw are not really consistent with expected trends. But then again, we are monitoring this. It is an experimental sensor. We are monitoring this data over time, and we'll report the trends over the years as we collect the data. So to quickly look at the performance of these test cells after year 2, what did we find? The most common distress, as you've seen from the photos there, would be a joint and corner spalling. We have noticed some progression in spalling and a little bit of additional distresses that have manifested that we saw in year 2. And then cell 2209, the ultra-high materials, which had 0% Portland cement, has been completely removed from the test site. And then in terms of ride quality, most of them were in the good ride quality zone. The only exception was cell 2214, the ash grove, the one with 35% calcine clay, exhibited slightly higher roughness in the 80 to 100 inches per mile when compared to the other test cells. In terms of friction, nothing out of the ordinary. The smooth tire friction numbers were consistently lower in year 2. And the low transfer efficiency values were mostly similar to year 1. Nothing to say there were significant differences. And that's it for the year 2 monitoring. And the next steps, we will be doing year 3 monitoring. And as you heard earlier from Ben, we planning on doing some additional construction starting in April. So we might try to get out there early to look at year 3 condition data. And we're also going to be using some video surveys to supplement field surveys for years 3 and 4 if you are unable to get out there in the field. And in terms of sustainability evaluation, we have surveyed the material producers to see if they had any information on carbon footprint from these materials. Again, not much was available in terms of environmental impacts or published environmental product declaration, but we are in touch with the manufacturers to obtain any environmental data that we can. And then we've developed system boundaries for life cycle assessment, and then we are going to be reaching out to the producers again to develop some assumptions for life cycle assessment, and this will be conducted using a lot of assumptions that will be documented. We will be using the FSW's LCA PAPE tool to document the environmental footprint from these materials. So that's it, and thank you for the time.
Thanks,
Any
Prasad.
questions? Yeah,
Yeah, I think we want to keep going. If you have
Okay.
questions,
Yep,
maybe
thank
talk
you.
to Prasad or Tom. But again, thanks, Prasad, for sharing that information. And again, there's a couple other contracts doing very similar things with a lot of those different concrete materials. So that's one of the four efforts, is that, Tom, that we have going on in that area. But let's move on to the Intelligent Construction team. Kyle, if you'd start it out and then hand it off to Sahil, that'd be great.
Sounds good. Thanks, Ben. Sahil, you can go ahead and share your screen, and I'll give a quick introduction here. So huge thanks to Sahil and his team for putting together surveys that I would say not only had questions that would get useful answers for us, but also they were done in a way where we were able to get a lot of participation. And that's just extremely critical for especially the intelligent construction technologies team, because you all are our clients, and people of all these different specific pavement related areas are the ones who are using these NDT devices or latest technologies. So with that, a huge thanks to Sahil's team, and then also a huge thanks to the people who helped distribute the surveys and of course the participants. And without further ado, go ahead and take it away, Sahil.
Thank you so much. What I would do, I will just defer to two of our fantastic PhD students that are working on these two projects intimately. This would be a good opportunity for them to present it. So the first one would be Isaac Zuniga, who will talk about the NDT. Go ahead, Isaac.
Thank you. So I'm just Isaac Zuniga. I'm the PhD student working on establishing applicability of NDT methods for project level evaluation. So I'll go right straight into the goals and objectives. So the first goal is to figure out how reliable different NDT methods are at identifying issues before they become significant. However, detection alone is not enough. Our second goal is to equip pavement engineers with the know-how to use the most effective NDT for the circumstance. Timing, method selection, and knowing how to use the data to make informed decisions is pertinent for pavement management. So with these two goals in mind, there are two crucial objectives for evaluating pavement conditions with NDTs. First, how capable and sensitive NDTs are. We want to be able to measure the confidence we have in each device's ability to detect defects reliably. And secondly, how accurately can we predict the pavement's response under different conditions and pavement types? So with these two goals and objectives in mind, a questionnaire was distributed sometime in late November, early December to a slew of DOTs and NRRA members to guide the project and move it forward. And that's what I'll present next. So the first three slides identify the respondents. So overwhelmingly, 84% of the responses we received of the 37 came from state DOTs, followed by private companies, universities, and associations, and an association, excuse me. So the next question was, how do respondents use NDT results? Overwhelmingly, they either use it for pavement management or structural design, followed by any forensic studies. Pavement maintenance was rounding out the top four responses. So the next question was, what is the respondent's role related to NDT usage? Again, about 76% use NDT results, 68% analyze NDT results, and less than 50% conduct NDT testing themselves. So for the most part, respondents use the end result data for pavement management related circumstances. So the next question was asking individuals to select 3 NDT methods that they were most interested in. So on the left, these are the most chosen devices. Overwhelmingly, 89% chose GPR, followed by 76% and 73% choosing TSD and FWD, respectively. And then about 54% of respondents also chose other devices, and I've listed them on the left-hand graph. Anything from infrared imaging to DFT, NDG, MIT scan. So just a slurry of different devices that these respondents were most interested in. With that most about three numbers of selection. So the next question was, which pavement distresses respondents encounter most? So cracking, overwhelmingly, 84% chose cracking, followed by delamination, debonding, and moisture-induced damage, rounding out the top 3 answers, or selections, excuse me. And then The next question was which properties or conditions respondents are most interested in detecting. So overwhelmingly, loss of structural strength and capacity was chosen as a number one response, followed by weak layers within the system, layer thicknesses, and then delamination debonding, rounding out the top four answers or responses, excuse me. And so with the three devices, FWD, GPR, and TSD, they were asked to provide any strengths, concerns, and limitations the device had. And so these were open-ended questions to remove any bias and allow respondents to provide whatever they think the best strengths, limitations, or concerns are of each device. So I purposely chose GPR FWD just because of the overwhelming response in those selections. But overwhelmingly, coverage and speed, we see a lot of respondents finding TSD a big strength as it can travel at highway speeds, collecting data, and you don't have to stop traffic flows. The next response was structural, excuse me, next categorization was structural assessments. So we see a lot of people or respondents selecting FWD as a big strength due to the back calculation of modulus and figuring out stiffness layers and your load bearing capacity. Accuracy of results is where we start getting a little bit less answers, but GPR, FWD rounding out those top two. And those were just any responses discussing the precision or reliability of results. I'll just discuss the top three of every graph. So the next was the concerns. So data interpretation challenges, we see a lot of responses with GPR. So these are responses that mention issues related to analyzing, understanding, or correlating data. So a lot of DOT responses, they understand how to get the data, but they don't understand what they're looking at with the data. And so that was a major thing with GPR specifically. Operational and safety concerns, we see a lot of responses with FWD, mainly because you have to close down roadways and you have vehicles traveling next to you while you're doing any testing. So these were just issues related to safety during operation or other logistical difficulties. And then the next organization was data reliability or accuracy. And these were just responses that raised concerns about variability, questionable results, or lack of precision in the data. For the most part, GPR, again, we see we don't understand what we're looking at. We can do the testing itself, but once we see all these little black lines and white lines, and we don't know what we're looking at. For the top three concerns from respondents. And lastly, were the limitations. The limitations overwhelmingly is operational challenges. We see a lot of people having operational challenges with FWD specifically. Again, you have to close down the road. You have to do spot tests. It's not continuous. Responses like that were rounding out operational challenges. TSD, mainly because there's only one device and it's costly to run. It's one of those devices that's kind of just new and out there, and a lot of those responses were just mentioning practical difficulties in deploying the device. The next limitation was training and expertise. Again, with GPR, a lot of responses specifically mentioning that it requires skills and interpretation of the data to understand what you're getting or what you're reading. So it just comes down to training for the most part with GPR. Next one was data quality issues. So this is where we kind of see a good mixture, 10, 7, and 8. So these are just responses that mention problems related to the reliability and accuracy of the data. For the most part, people can get it, but they don't know if it's correct. With that, I leave it to questions, or I send it back to Kyle because I don't think I have any time for questions. But I try to do that as fast as possible. Thank you.
Yeah, I think let's leave the questions if we have time till after the TSD results. Thanks for sharing that. Like I said, it's really nice to see, as long as we're following the results of the survey, that hopefully our end product from these projects are going to be something that the end users will be interested in. So with that, we will move on to the TSD results.
Oh, thank you very much. Reza Kamalizad is another PhD student of ours that is going to present that. Go ahead, Reza.
Thank you, Dr. Nazarian. So hello, everyone. I want to talk about the results of our online survey for the project we are working on, which is the effective use of traffic speed deflection devices for network-based and project-based applications. So first of all, I want to quickly talk about the goals of this project. We have three main purposes or goals for this project. The first one is to develop some guidelines to maximize the extracted information from TSD data for network level or project level applications. The second goal is to minimize the data collection costs for agencies. And the third goal is to recommend some methods to make the device and data collection and analysis procedures even better. So to achieve these goals, we have two main focuses. In the first one, we want to develop some guidelines for classifying pavement sections based on structural soundness categories and also structural based indices. And also we want to evaluate the possibility of using TSD in project-based applications, for example, back calculation of pavement modulus or estimation of a structural capacity for different pavement sections. So we distributed an online survey for this project, and we got 42 different responses. And from that, 17 worked for highway agencies and 25 were either researchers or from private industry. And from the respondents, fortunately, 93% indicated that they had experience to work with TSD. So the first question was about the total survey length, and we had some interesting results and impressive coverage of road network for some organizations. And we had 3 organizations that use TSD on more than 50,000 kilometers of the road network, which shows us how actually quickly we can gather structural data using TSD. The other actually question was about the data collection level of organizations. As you can see from the results, most of the organizations were focused on using TSD data for both network level and project level applications. But after that, some actually organizations merely focused on network level applications of TSD results, and only 3 organizations solely focused on project level applications. Actually, one of the most interesting questions was, what is the property of interest that the agencies or organizations can use TSD to detect in pavement structures? And as you can see, first I wanted to mention that the sum of these numbers for some questions is more than 42, because the respondents could answer more than one actually option. So the first most sought for property was loss of structural strength and capacity, as Isaac also mentioned in NDT project. The next one is to detect the weak layers within the pavement structures. And after that is the joint condition investigations for rigid pavements. And the last one is investigating delamination and debonding in pavement structures. So also we asked about the method that organizations use for analyzing TSD data. The most focus is to estimate structural indices, and also many focus on converting the deflection velocities, which is what TSD measures, to deflection data. And after that, it is back calculation of layer modulus and also calculating load transfer efficiency, or LTE. Another important question is the practical application of TSD data. When we ask organizations, most of them answered that they are focusing on using the estimated deflections, not the deflection velocities, for their network level pavement management system. And after that, it was using, again, the estimated deflection for project level design purposes. But as you can see, there is not a lot of focus in organizations right now using deflection velocity data for network level or project level applications. But from the literature search, we found that there is a growing interest of using deflection velocities instead of vertical deflections, because that is the parameter that actually TSD measures. So we also ask about the strengths and concerns and the weaknesses of TSD. As far as strengths are concerned, most of the respondents says that speed and safety of the device compared to more traditional NDT methods is the most actually promising strength, and also the fact that we can detect the anomalies throughout our road network very fast is another strength of TSDDs. As far as concerns or weaknesses, we divided them to two categories. One for flexible pavement structures, where the respondent says that the precision and the lack of good threshold values for the acceptable precision of TSD data is one of the main concerns. Also, the performance and measurements and accuracy of measurements of TSD on thicker flexible pavements is concerning right now. And also the lack of an standardized temperature adjustment procedure for TSD data, along with the methods and the performance of the methods used for converting deflection velocities to deflection values, and also the lack of a robust back calculation tool for TSD specific measurements is the main concerns for flexible pavements. As far as rigid pavements are concerned, the very small deflection parameters and the fact that it may be lower than the accuracy of the device is the main concern. And after that, we have concerns also about the precision and threshold values for rigid pavements, and we have some concerns about the ability of actually assess foundation layers below the rigid pavements using TSD data is the last concern of the device. So sorry if I talked too fast, and thank you for listening. If you have any questions or suggestions or ideas, I would be more than glad to hear.
Thank you very much. Back to you, Ben.
Yeah, thank you very much for those two presentations. People will get back to you if they have questions. So thank you. Our next presenter, again, I forgot to mention Tyler Hunt is the preventative maintenance team leader. But Tyler, if you could take it from here and introduce Dan for the rumble strip study update.
Thanks, Ben. I'll be kind of quick, so we're maybe running a little short on time. So Dan, if you want to go ahead and pull up your presentation. Sure. Dan Schwartz from Asphalt Materials is here to present on our recent task force submittal for materials-based methods to improve rumble strip durability. I think with that, you can just take it away, Dan. I won't waste any more time.
All right. Sounds good, Tyler. Can you see that? Tyler, can you just give me an okay on that screen?
Yep, we can see it, Dan. Thanks.
Perfect. Well, yeah, let's see if we can make up a little bit of time here. This project's a joint effort between the Flex and preservation teams. Tyler's obviously the liaison for it. And as the name suggests, obviously what we're studying is rumble strip durability, specifically centerline rumble strip durability. As these photos would indicate, this is all done on road cores. So these were projects that were built in 2023, cored, and then tested in the laboratory. not to delay here. So getting into the objectives, very basically, understand whether the installation of rumble strips impacts joint performance directly, or whether they set up the joint for accelerated failure. We might call that something like durability, right, in our industry. Secondly, whether there's damage that occurs or not, can material type treatments offset this damage or increase reliability of joint performance? So the third objective listed here is really a safeguard against inhibiting the purpose of a rumble strip, which is as a safety tool. For that, I'll point you to the NCHRP report 1107, which came out in 2024. Does a great job of quantifying what does it mean for a rumble strip to be safe. And we actually hired those folks as a subcontractor on this project to evaluate noise performance. And then lastly, not the point here, is to develop sort of best practice guidelines. So different scenarios, design scenarios, reliability scenarios, what kind of treatment options would an agency have when they're building a longitudinal joint? Very quickly, the takeaway here, I'm going to point you to the NRRA website for this project. Lauren does a great job keeping that updated for us. All the task reports and data and slide decks and so forth are posted there. All this Gantt chart is to say that we're a little ahead of schedule, but we've submitted now the meat and potatoes of the project. It's a matter of review and then finalizing a report and best practices, not to be taken lightly, but the bulk of the actual labor part of it is all done. So that's where we stand with this project. I'd be remiss given this group not to show some data at least. So this slide basically gives an example of how we presented the data, but it's also one of the more significant findings. Again, keep in mind this is all on road cores and road cores with all of their flaws, namely variability in construction and materials and so forth. But what you're looking at here, for those of you familiar with asphalt mixture testing, this is data from an overlay tester. The overlay tester gives you two parameters. One is fracture energy, less important for a longitudinal joint, but the other is crack progression rate. So this is like how quickly the crack grows with subsequent strain events. So it's like a fatigue type test, which does make sense for a joint. And what this is showing, using a statistical grouping analysis here, is that the installation of rumble strips actually does, statistically anyway, increase the crack progression rate at the joint, and that material treatments to varying degrees of success can offset that. All right, so again, just an example, one snapshot of the several test methods that we use, kind of showing how we went about answering our objectives. So with that in mind, to come back to the objectives and just to keep us on track, does the installation of centerline rumble strips for these project scenarios impact joint durability? The answer is yes, but the short-term impacts at least are overshadowed by the presence of the joint itself. My friend Raul at the beginning of this entire meeting here today used the word discontinuity, and I think there's probably not a better word than that for a cold construction joint in hot mix anyway. So the presence of that discontinuity is really what controls the performance. It's not really the rumble strip itself. So in other words to say is build a good quality joint, and installing rumble strips is probably not the boogeyman that some may believe. But keep in mind that this is all short-term performance. We had significant issues with trying to age these field cores and evaluate long-term. In our industry, the hot mix industry, durability is generally discussed in the context of long-term. So what we found is that, look, a lot of these trends are project-specific. They could even be material-specific to a certain project. So investigating longer-term durability is probably in our best interest. And we talked a little bit about within our TAP, if there was interest in submitting an idea to use these projects. They're already built. They'll be undergoing, as of 2025, that'd be 3 years. So by the time something would get contracted, 4 or 5 years of service, might be a good idea to go back to them and see if any of these trends hold up. But again, I wanted to be brief here just to keep us on track. The project website's a good resource. Tyler or myself can answer questions. But that's what we're learning on centerline rumble strips and hopefully more to come in the future. So Tyler, I'll turn it back over to you. That's what I've got for you this morning.
Thanks a lot, Dan. Ben, do you want us, since we have about 18 minutes left or so, do you want us to just wait on questions till the end?
Yeah, just
if we
hold
have time.
off. I think
Okay.
Dan, you did a great job explaining what's happening, and people can contact you. So
Sounds
we'll
good.
leave it at that. Kurt, you want to bring us home with the flexible team and the project you're highlighting with Chen Chen? So when you ask, can I see your presentation? I could. No, I can't.
Yeah.
You had it there. Then it went away.
Oh, there we are.
There you
Okay.
are. So it's
Okay,
not in
thanks.
presentation mode, but
Yeah. Thanks, Ben. And so welcome everyone to the flexible teams portion here. So just a couple things before we get into the highlighted project here. We've got some timelines here that we put together here for kind of a path to get to where we want to with the goal of the $100,000 funding. So we'd like to, we emailed out the team here at the end of the month and trying to get some ideas for the funding. And so we'd like to, we haven't set a date, but maybe in the middle of the month we can maybe get together and kind of go over some of the ideas that we're getting. And then by the 1st of March, we'd like to start, voting on them and eventually and get to the point where we want to get these ideas submitted by the 15th or so of March. Everything is open right now as far as what you would like to, it's either research or something that we can put on the test track or something to that effect, lab research or anything's on the table. So, and then I think we'll leave it up to the agency members to determine a winner from the goals, and then we want to get them set in. So we'd like to also, encourage any collaboration with the PM team or others that we could kind of work with as well. So moving forward with that, then Chen Chen from the National Center for Asphalt Technology who is an assistant research professor there, is going to give us an update today on the standardization of the SIP calculation for Hamburg wheel tracking test. And so it's just the SIP is just the stripping inflection point that the Hamburg wheel gives us. It doesn't always give us. The need was that it was generated a lot of interest. So we made it a research project among the members, and it's not really well defined. So the purpose of this research is to automate and establish a standard for it, so that it's easier for the state highways to make decisions based on what they get. So with that, I'm going to stop sharing and turn it over to Chen Chen, and go ahead, Chen.
And Kurt, thank you for introduction. And I'm going to start to present my presentation. Let me share my screen. Can you see it?
Yes, you can.
Okay, great. Okay, so as Kurt mentioned, this is like the 2023 NRRA FlexTeam project focused on the standardization of SIP calculation for Hamburg. So hold on. And this is our research team and panel and our complex task force. The team including Femi and Chili is our software developer. And I would like to say thank you to the panel and the complex force, because They give us valuable comments when we develop this software, and this is something we cannot do without their help. So I would like to give a little bit background about this project. So Hamburg is a very popular testing among state highway agency and contractors. Typically, Hamburg can be used to evaluate rutting resistance and moisture resistance. If you can see in the left figure here, based on our survey, there's about 31 states are using Hamburg for different purposes, make design, research, and QCQA. So long story short, Hamburg is a very popular test, and a lot of people are using it to doing our routine work. And SIP, which means stripping inflection point, is a parameter developed in the AASHTO T324, which is used to indicate the moisture stability. And as you can see in the figure, basically SIP is interaction is like intersect of two lines. One line called one line. This line called strip line. This line called the clip line. So even in the standard, we clearly say, okay, SIP is the intersection of these two lines, but there's no standard method to calculate these two lines. So some people can just use eyeball to draw two lines and get SIP number. So the challenge for SIP is we cannot accurately calculate SIP, especially for the Hamburg sample, which have a little bit of stripping. So some people may from the eyeball say there's no stripping. Some people say there's stripping. So there's always a confusing or dispute between different people. And there may be a dispute between agency and contractors. And another thing I mentioned earlier is there's so many different methods are available. Different vendor, different agency are used to analysis to calculate the SIP, but the number are not same. As you can see in this table, for the same raw data, if we use different methods to analyze the data, as you can see, the SIP number can vary from 400 to over 11,000. That's such a big, huge data, like a range. So if the state SIP criteria is minimum 10,000, so the mix pass or fail. That's a tough question for agency, also tough question for the contractors. So which means we need a standard method to calculate SIP to avoid dispute among agencies or between agency and contractors. So, and also after we standardize the method, we would like to develop a Hamburg data analysis software, so which will make our life easier. So you just upload the raw file, so you can just get the final results. This way we can avoid the subject data manipulation and interpretation. So basically, some people, for example, some people may use some people may from the raw data may select different data set to do data analysis. So, but if we use software, you just upload, you cannot change the raw file. So the raw file, you just need to upload the raw file and then the software will give you everything. In that way, it will make our life easier and also will avoid dispute between agency and contractors. And the first task we did for this project is we collect information. We did a survey among agencies and the Hamburg manufacturers to summarize existing methods to calculate SIP. We have 7 methods, but not all of them, they are not always give us comparable results. So, the team and the panel will work together, critically review each method to identify the pros and cons for each method, and then finally we select the most robust method to develop the software. So here is a quick summary about the selected SIP method. Basically, long story short, we use Frank model to fit the raw data. Then based on after fit, we use the fit equation to to define the stripping point, to define the stripping line and creep line. As I mentioned earlier, the difficult thing is we know we need 2 lines to get intersection to get SIP, but what's the standard way to define these 2 lines? So after you have the equation, we have a standard way to define the creep line and strip line. So you will have the SIP number here. So you are more than welcome to review, to read our report. So there you will able to see how other people use different methods and how they are compared to each other. So, after we fit the data, do data analysis, there are a bunch of test parameters are available. So the actual parameters which is defined in the actual standard. So there are so many parameters here. And also from our study like a few years ago, we also have some additional parameters like stripping number and correct rod depth. The stripping number mean like from which point the mixture start to strip, to have stripping issues. And the correct rod depth means, okay, people may be curious, if there's no stripping happen, what's the final rod depth? Because Hamburg rolling Hamburg was like tested on underwater. If there's no stripping, so the curve will give you will show the rotting resistance, show only the rotting resistance. But if there's stripping, so the final rod depth is like a combined parameter from rotting and stripping. So the corrected rod depth can give us a straightforward meaning about, okay, what can help us to separate rotting and stripping. So if there's no stripping, what's the rod depth will be? So the quick slope and correct rod depth is like pure rotting parameters, and like the stripping slope, SIP and SA number is pure moisture parameters, and the remaining are combined parameters, which means these parameters are affected by both rotting and moisture. Okay, the test tool is after we select the method, we just go ahead to develop our software. The software is a web-based program on Open University server, and the logo is still under development. It's almost there. And we are happy to have 3 manufacturers to support us, which are Geotech, PTR, and Troxler. And we have 40 files. So besides the 3 files from the 3 manufacturers, we also create like 1 file, mean people can just create their own file, use 1 single Excel. So if you don't want to upload the raw file, you can just copy the data you want to analyze, just upload it. So user management function is not available by now because there's a lot of work from the software side. Basically, there's no single account for each person. So this is a program website now, and it's very simple. So you have 4 program layout: home, upload files, then you can analyze the results, then you can see the information about the program. And the draft user manual already available, and the software currently is under alpha testing within the team, type number, and also the equipped manufacturer. We should be able to get everything finalized by the end of this month, so then we can spread out to agencies and contractors for further testing. Here is a quick show about the software. So here is the home screen. So basically, they summarize all the file you analyzed. And then here you are going to select the file, which equipment you are using, then choose the file you want analysis, then upload. After you upload, the software will tell you, okay, the file was uploaded successfully. Then you click this little button here, you can see do analysis. After that, you're going to have your analysis result here, like here. If you click this like a bar single here, you're going to have the data analysis. Not only we plot the figure here to help you to better understand the data analysis. For example, we can show you the the raw data and the fit data. As you can see, they fit pretty well. And then you can have the creep line and stripping line and show you the SIP number. As I mentioned, we have so many different parameters. So, you can also this is the interaction diagram. So basically you can click on, if you want to see some parameters, you can click it. If you don't want to see it, unclick it. That should be very easy for you to understand. So it's not only a raw data, it's not only some parameter number, but also you can have like a diagram for you to play with it. Then this is like a summary of all the test results. So we'll show you the file name, file format, the data you analysis, and also including all the parameters from actual and the additional parameters. For example, if you have left and right wheel, we will give you average and also the difference. And we totally understand maybe sometimes the left and right wheel may not be the same mixtures. In this case, you may just want to say that you may just want to do data analysis by yourself to separate the left and right. And then you can just click the export to PDF. This will give you a official PDF report. So basically, very simple, just upload the file, then export to the PDF, that's all. Next task, but maybe sometime next month, we are going to distribute the software to the agency for beta testing. We are going to conduct a web meeting to collect feedback. Based on feedback, we are going to further improve our software. The last task will be like, we are going to release the software for public use, and we're going to develop final reports for summarize our research efforts and conduct NRRA payoff webinar to introduce software user manual and other findings from the project. And that's all. I think I got it perfectly. 1 minute left.
Yeah, Jen, you're great.
Thank you.
Thomas had a question, but I think, could you take a look at the chat and maybe touch upon that a little bit? And Kurt, if I may, I'm going to kind of wrap us up so we can get going.
Okay, very good. Yep.
We had 106
Thank you,
people
Chad.
here, and it was really fun to look over the people. Really appreciate your time for NRRA and your interest in NRRA and your friendship. It was nice seeing your names, and each one of you had brought a smile to my face seeing your name there. So thanks for being a part of it. Saw a guy from Finland that we're probably keeping him up. It's 8 o'clock there. He's joined us, Timo. Thanks for joining us, Timo. And just like a glass of warm milk, we're probably getting him ready for bed. So that's great. Again, next month we're going to turn back to our normal team meetings, monthly team meetings. So again, you'll see that on your calendars, and please stay active in NRRA and have a good rest of the day. Thanks, everyone.
Thanks.
Yeah, thank you.
Thank you.